Hey Algebon, here are the notes for 8.1 monomials and multiplying them. So what is a monomial? Well, we're going to look at this word and see the mono root. What that means is 1. So a monomial is a number, a variable, or product of the two. And an example of this would be something like 4, a number, x, a variable, and 4x, a product of the two. So then if we look a little further and we look at what it means to simplify a monomial, it means to combine or to reduce as far as possible. All right, let's switch gears just a little bit. Who remembers what an exponent is? An exponent is something that looks like this. It is the idea that we have a base raised to a number. And the two components are the base itself and the exponent itself. So an example of this looks like 3 to the 2. This is the base, this is the exponent. And if we write this out, what this means is that we're going to multiply 3 by itself as many times as my exponent says. So I put my base and then I put it 2 times. And then I simplify. 3 times 3 is 9. So my final answer for this exponent would be 9. So what happens when we multiply exponents? And can we come up with a formula? Well, I think it's helpful to look here at what these look like written out. So x squared times x5 is x squared times x to the 5th. And if we count up how many x's we have 7 x's multiplied by each other. So our final answer here is x to the 7. Let's look at that again and see if the case holds with a different letter. If I have w to the 3rd, that means I have 3 w's times 3 w's. Total, there are 6 w's. So if I'm not mistaken, what it looks like is happening is we are adding our exponents when we multiply. Now, this isn't always easy to see, because what if we have something like n to the 3rd times m to the 5th? These two can't be combined because they have different bases. We can only add the exponents if they have the same base. So the final answer for this problem is just the original question because we cannot combine. So a good formula for this is if you have x to the m times x to the n, it's going to equal the base, because they're the same, to the m minus n. I'm sorry, the n plus n. M plus n. You can also write if same base, add exponents as a little reminder of what we're doing there. So let's look at this a little further. Remember, we want to simplify as far as possible. So with this one, I'm going to write this one out the long way. I'm going to write everything in parentheses. I have a 3, 1, 2, 3, 4, 5, 6 x's. I have a 5, and then I have 2 more x's. Notice how these are each distinct terms. They're all separate from each other because each one could be rearranged to say the same thing. For example, 3x to the 6th could be the same as x to the 6 times 3. So if I moved these two, it wouldn't change the problem. And that's actually what I'm going to do, is I'm going to move the x's to be together, and I'm going to move the numbers to be together. So 3 times 5 is 15, and 6x times 2x is going to be 8 total x. Now, I don't expect you to show your work like this every time. This can get really, really long. It can be a lot of work. But it's good to see what's happening. So if you don't know if your answer is right, write it out the long way to check. All right, let's keep going. This one, I'm going to write it out the same way, but I'm not going to do it quite as much. I'm just going to say 4, A3, B, the 3, A squared, B5. Again, I want to group those like terms. So I want to group the 4 and the 3. And then I'm going to add the B and the B. And then finally, I'm left with the A's. So what does that look like when we simplify? Well, negative 4 times 3 is negative 12. A3 times A2, we add their exponents, so we get A5. And then B doesn't have an exponent, but it's technically an imaginary 1 because there's one B. So B1 and B5 becomes B6. And that's our final answer. Because we cannot simplify or reduce or combine anything, this is our final answer. All right, I encourage you to pause the video here and see if you can do these. When you're done, unpause the video and I'll show you how to walk through them. All right, hopefully you pause that video and check to see your understanding thus far. So these ones, same thing. I'm going to multiply the like terms. I've got a 2 and an 8, so I multiply those to 16. And then I add the exponents of the things with the same base. Let's see it again. I have an x squared and an x, so that becomes x3. I have a y and a y3, that becomes y4. And I have a 4. Now, I don't usually care too much about what order the letters go in, but I do always prefer that your coefficient is out front. So the same way that we had 16 out front here, I want 4 out front here, even though it started in the middle. All right, one last one. Even though this has 3 terms, we do the same exact thing. We're going to combine those like terms. Negative 5 and 4 becomes negative 20. My x1 and my x2 becomes x to the 3. And my y and my y4 become y5. I've now checked off every little piece. I don't forget anything. And that is my final answer. Let me know if you have any questions.